Hi and welcome, my name is Joshua from Tagg. In today's video, we would build on what we did in the previous videos on how to import data sets from our folder on our computer to our RStudio platform. And I want to believe by now, for those of us that have been following videos on this channel, will have a good understanding on how to do this. And if peradventure this is your first time on my channel, I would plead with you to try and subscribe and also share with your colleagues so we can all learn together. So in today's video, I want to introduce us to an important concept in arrow programming, and that is a loop, the concept of loop statements. And we'll see how we can apply this on vector and at the same time on data frame. But before we go into what we have for today, I just want to take our mind back to some of the things we've done in the previous video. So first, we have talked about working directory. Control 1, get working directory for us to know the folder our RStudio is connected to at the moment. So when I run this, by default, it is always connected to the folder documents. So the data set we want to use in this video for practice is this data set called trees. It's a default data set in RStudio, and for you to get more information on this data set, just put the question mark and then you run it, Ctrl Enter, and you wait for this particular documentation over here on the help pane, and you could see it provides information on the diameter, the height, and the volume for black cherry trees. Now don't forget we have length, this function called head, and you put trees. What we're expecting is the first 6 observations of this data set, and you could see the first column is get, which is diameter, and the second column is height, and the last column is volume. So with this, one of the things I just want to share with us briefly is how can we write out our result out of RStudio and save it in a data set and store it in the folder arrow is connected to. So this is what I mean. We're going to learn how to use this function write.csv, and then the first argument is your result, which in most times is in a data frame format, or it could be in the form of a matrix. So you could say this, and then the next argument will be what name do you want to call that data set, and you put the complementary extension. So let's say I want to call this DAT dot the extension I want to write it out. Don't forget we're using write.csv, so I'm writing it out as a CSV file. So if I run this, you won't see anything on the global environment, but if you go check the folder we're connected to, which is document, and you look for DAT, we're expecting to see, okay, this is DAT. So it is already written out now as a data set here. So let's go back to our RStudio. So then let's take for instance that we are just starting work, and your intention is to load a data set into R, and the data set we want to use for this particular work is that same that we have in the document folder. So how do you bring it in? We've done that in the previous video, and we learned how we can use this read.csv function, but I'll comment this because this is not what we are doing at the moment. Let me go again and comment, Ctrl+Shift+C. So let's learn how we can use the global environment. I'm just revising what we've done before. So you see from test, and then we're looking for that DAT data set, and so we scroll, and so here it is. You open, and then you can decide to change the name here. We have automatic, the encoding, you leave it as it is. The row names, leave it as automatic. It gives the 1, 2, 3. The separator that is used is comma, and then the period, which is the decimal, is period. It is not comma. In some cases, in some regions, they use comma. Like where we are in Italy, they use this particular command. That is why most times they use the rate.csv2 when reading in the data set. So we have this double quote is present, and then just scroll down and then you click on import. So when you check the global environment, we have 31 observations of 4 variables. Now when we import this particular data set into R, we have an additional column which is not part of what we want. So that's the first thing we will do. So we would say that, and we'll say that again. We're assigning, and we'll say -1. That is, I'm not interested in the first column that we have in the data set. That, so that is done, and now we are now back to having it as 3 column as it is. So now let's move to what we have for today, and that is the loop statement. Control 1, and that's the loop statements. So the first loop statement we'll talk about is the for loop. And what exactly does this for loop does for us? I'm just going to provide an explanation. So a for loop in our program, what it does is we use it, it is used to iterate over a vector in R. So I'm just going to provide an example, and for it to be very easy for us, I'm going to create a variable, and I will call that variable VAC. So we would say it is numeric, and we just want 5 of it. So what we are doing here is we are creating empty values, 5 of them, 5 numeric empty values, and we are storing it in the variable called vec. If you check the video I did on how to create variable in our programming, you would see this particular thing. So let's move on. Then I run this. When you check the global environment, we now have a new section for values, and you could see these are empty numeric values stored in the variable called vec. So we're going to use this function. We have used it before, like I said, it's just a recap. So then I'm going to put in vec, and look at what will happen. You have this particular box, and then you can fill in the values. Let's say the first value is 4, 1, 6, 5, and 9. So when you are done, you close, check what happened on the global environment. The values have been updated, so they are no longer empty, they are now filled with a certain value. So if you check vec and you run vec, you'll see vec now has 4, 1, 6, and 9. So how do we apply the for loop on this particular vector? So look at, you say 4, and then you open a bracket, then you can use, let's say I, let's start with using observation I in vec, and then you put an expression. That is, the expression you want to put is as long as the condition we have inside this particular parenthesis is fulfilled, then do what we have inside this curly bracket. So what I want you to do first, for us to have an understanding of what is going on, is to print I. So if I run everything we have here, you can decide to highlight everything, or you just put your cursor at the beginning of the code for the for statements, starting from line 21, and then when you run it, you could see what it's doing here is this. Now what we have, this particular vec is a vector, and for each of the iteration that we have, the I that we have, take the value of each of the vec, goes into the expression, and then go back again, take the next value that we have in vec, run the expression with it, go back again, take the next value, which is 6, print 6, go back again into the loop, take the next value that we have for vec, which is 5, print it out, and does this until it gets to the last value, which is 9. So let's take for instance that I am interested in doing something more aside just printing out the values for the observations we have in vec. So I can say 4, and I say I in vec, and then I put the curly bracket. So whatever you want, whatever thing you want to perform, as soon as that condition is in the parentheses is fulfilled, is what you will have in the curly bracket. So let's take, for instance, I want something of this form: I raised to the power of 2 divided by 4. Yeah, divided by 4. So if I run this entire thing, look at what will happen. Nothing happens. So what is the reason why we don't have anything happening, except the fact that we have I as 9? So what happened is that, don't forget I said I takes the value of each of the values we have in vec. So for the first iteration, I takes 4, it goes round, print this whole thing, go back again, print it, go back again, until we have this 9 last value, which is what we have for I. So in case you want to see what is going on underground inside the loop, what you need to do, let's copy what we have there. You all just need to say print and then paste what we have in the expression, then run the entire thing, and you could see this is exactly what we want to do. Like the first observation we have in this is 4 raised to power 2, which is 16. When you divide it by 4, it gives you this. So when it goes again, it prints it. It goes again, it prints it. It goes again, it prints it. And you could see for the first rows. So having done this, now having this understanding, the next thing I think we need to do, which is the best thing, and that's what I used to do most times, is to have a clearer understanding of what is going on in that loop. I would say 4 in vec, and then I put the curly bracket. So let me copy what it already copied, then I will assign a variable inside that same for loop, and then I can say print. Okay, so you can choose to highlight everything, or you run once, and then we have the same thing that we have earlier in line 25 to line 28. So let's proceed and see how we can use this for loop again on vector. So we have, let's see how we can use it in denoting an odd number or even number. So this is what I mean. So we will look at vec. If the first observation is even, it will write even. If the next is not even, otherwise it will write odd. This is even, it will write even. This is odd, I want it to write odd. And this is odd again, I want it to write odd. So how do we do this? And this is another very important thing I want us to learn. So I'm going to say the nature, I'm going to say nat in this way. That is the nature of each of the observations, whether they are odd or even. So I'll say it is a character, don't forget, and I just want it to just pick up one character, which is either odd or even. So I go and then I write the first statement in this way. Just pay attention, and then thereafter if you have any question you can ask. So I say for I in vec this. Now look at what I'm going to say. I'm saying if, I'm using this if statement now. I'm saying if I %%, and then I say divide by 2. If this is equal to 0, that shows that particular value is even. That is when you divide the number by 2, it doesn't have any kind of remainder. So I can use this curly bracket again, or I can choose not to use it. It is not compulsory. And then what do I want to happen to? Then I'll say nature, which is the counter we use on the outside. And I'll say let nature be even. Let nature be, I paste even. And then if otherwise, which is x, let nature I paste again. Otherwise, if it is not even, definitely it's going to be odd. And then when you are done with this, just as we have in the first case when we were printing each values of k, print each of those values. Good. So print nature. So let's see what will happen. So if I run this entire line of code now, you could see the first value that we have here is even, the next is odd, the next is even, odd, and odd. So let me quickly explain what is going on inside this loop. So we say for I in vec. So what this means is for each of the iteration, I goes into the loop with the values, each of the values we have in the variable vec. So the first thing that goes into this loop is the first value we have in vec. That's the value I takes into the loop for the first time. And so it says 4 divided by 2 is the result equal to 0. Yes, it is equal to 0. So this condition is fulfilled. As soon as this condition is fulfilled, do what we have inside this part of the if statement. That is, paste even inside this particular empty character, and then it does that. So it doesn't care about this part of the loop because the condition is fulfilled. This part of the loop only runs if this condition is not fulfilled, and then thereafter it prints nature, which is what we have here, even. It goes into the loop again and starts iteration, but this time around not with 4. I takes the value of the second value that we have in the vec variable, and then it says 1 divided by, definitely this is not going to give us 0. So since that condition is not fulfilled, the expression we have inside the curly bracket will not run. Otherwise, this is s, this is what we're going to have. So it's going to paste odd, and then finally it prints nature. That is how we have odd, and it keeps doing this until it gets to the last value we have in the variable vec. So finally, for this first part of this series, let's learn how we can count even numbers present in vec. So to do this, definitely we're going to have like a counter. So we create this and we run it on the global environment. We say count is 0, and then we say for I in vec, and then we put the curly bracket, then we put the condition. If we have this observation, we divide it by 2 and it gives us 0, then you can choose to use this curly bracket and you may not choose. So update the value of count. So we say count is assigned to add 1. If that condition is fulfilled, that's +1. And then let's see what will happen. And eventually in the end, you can say print, you can run print count. So let's run this whole thing and let's print count. So count tells us the result is 2. And what does it mean? It means in this variable vec, only 2 of it are even, and that is what we have in 4 and the other one that we have in 6. So what is happening here? One of the reasons why we created a counter, we always like to do this to make this particular statement very easy. So I takes the first value, which is 4, goes into the loop and says I percent this equals 2. So this is true, and so the moment this is true, then this is going to be to run, and that is count will now be count plus 1. That is count, which we have by default to be 0. This is it here. You add 1 to it. So the value of count has been updated to 1. It moves again, goes to 1. This condition is not fulfilled here. So everything we have here will not run. It moves again, takes the value of 6, and then this particular condition is fulfilled. Then count, in this case, I've changed to 1, and then the count we'll be using in the case of 6 would now be, this one will be 1 plus 1, which is 2. It goes again into the loop with the value of 5, and then the condition is not fulfilled. This will not run. It breaks out of the loop, goes into the loop again with the last value in the variable vec. At the same time, the condition is not fulfilled. This will not run. So if we print our count, we have the value of 2. So I want to believe we have learned a lot of things from this first part of the series on loop statements in R. I will be glad if you stay tuned, for the next video. Thank you very much for your time. God bless you.